Hi, I'm Keith Witek. I'm the Chief Operating Officer of Tenstorrent.
So hi everyone, you may recognize this place, this venue as Tenstorrent's building here in Santa Clara, California. I'm here again. And as part of this interview series, you may have seen me interview Jim or Wei-han. David, we interviewed him yesterday, but today I've got this guy. This is Keith Witek, their Chief Operating Officer. Good to see you, Keith.
Pleasure to be here. Nice to see you again.
Now, you guys might not know who Keith is. I'm going to let Keith explain who he is and what he does, because it's a very impressive track record.
Oh, thank you. So, I started my career, electrical engineering, computer scientist, got both those degrees. Went off and did engineering research, semiconductor fab. Was fun. And then I called my father one day and said, Dad, I think I've decided to go back to law school. And I thought he was going to cry, right? And he was like, the family suffered to get you through University of Wisconsin, and you're going to be a great engineer, and now you've blown it. And
do you come from a family of engineers?
No, actually, not very many at all. So I was one of the few in the family to go to college from the Midwest. So and then when I went to law school, started on a legal career, I quickly morphed that into a business career. Been to AMD, Motorola, Wilson Sonsini, my legal days, Tesla, Google, SiFive, and now I'm coming here to Tenstorrent. And what I do is like taking businesses that are facing complex challenges and complex opportunities, and using the combination of business, law, finance, technology, using that information that I've got in my head, pulling together teams that go make complicated things happen. And it's been a great career. I've had a lot of fun.
So before you joined Tenstorrent, were you aware of Jim? Were you aware of the company?
Yeah, I was very aware of Jim. So Jim and I worked together at AMD. And AMD, what a fantastic story. It's been, like the darling of the tech business for the last, 6-7 years. So Jim and I were there together. He did the Zeppelin technology. I was running strategy and corporate development at the time. And so we went down some pretty challenging paths on chiplets and other technology, bring it to market, which I think is going to be profound for the industry, by the way. Maybe someday we'll have a chance to talk about that.
We can argue about that.
Yeah, exactly. I would love to hear your point of view on that. So Jim and I worked to bring that technology to market with, Lisa Su and Papermaster and all the folks that are there, and it was fantastic. And then we went to Tenstorrent together, brought up Autopilot 3, launched Autopilot 4. We're working
Tesla's together.
Oh, what did I say?
Tenstorrent.
Oh, yeah, I'm jumping ahead. So no, I went to Tesla.
It's that exciting.
Yeah, exactly. Well, Tenstorrent, we might buy Tesla. So,
okay.
Yeah. So, so I went to Tesla together. We did Autopilot 3, Autopilot 4 together. And then I went off to Google. He went off to Intel. We figured, time to go do some interesting stuff that'll change the market, because RISC-V coming to market, interesting. AI coming to market, interesting, for reasons that I'm sure you completely understand. And the timing was right. And the people are right. The team is great. The market conditions are right. And I'm having a blast. It's a lot of fun. And I've had fun before with Jim, and the team he's attracted to is phenomenal, and I wanted to be a part of it.
So you've been here for about 7 months now.
Yeah.
Do you feel like you're fully got your hands deep and you can understand every nook and cranny?
Actually, surprisingly, it's getting close to answering completely yes. Jim and I were talking about this just yesterday. I've been here 7 months, but it feels like 7 years. And I'm sure you've had those roles, right?
And the power of a startup.
Yeah, and in good ways. Just we were looking back and reflecting on the things we've done just in the past 7 months, and it was extraordinary.
So Chief Operating Officer. Now it's a term that I'm sure many of us have heard of, but none of us really know what that means.
Yeah. No, it's a lot of complicated things. And for each company in different business models, it means different things, right? So for Tenstorrent, Chief Operating Officer, what I'm doing is I'm pulling together all of the channels to market, basically. We've got to develop, at Tenstorrent, it's a complicated path to market and across many paths to market. So it's IP we've got to license. It's chiplets we've got to build in a chiplet ecosystem, standalone SoCs, cards, boards. We've got cloud where people can get onto our system, play with the system, program it, test it out before they buy. So all those channels to market are all complicated and different. I've got to make sure they're happening. So through manufacturing, through monetization, through partnerships, through support, quality for the technology, my team is building that. And the cool thing about working at Tenstorrent versus like an Intel, at Intel, you're operating a process that somebody developed 40 years ago. Mm-hmm. Here, we've got to build that while we're driving down the road at 70 miles an hour. So it's a very different, you need builders that aren't afraid of chaos. And so I'm looking for those people to hire, right? Builders that aren't afraid of complete chaos, and there's not a lot of process and systems around them. We've got to build that.
Yep.
And then I've got law, the legal group, HR, facilities, the IP licensing business. Those are the teams I'm building out and trying to make successful here at Tenstorrent.
So for 7 months, that was probably around the time that I started working with these guys as well. And it amazed me back then that the company at that point was about 6 years old.
Yep.
They'd done up to the third generation product, roadmap out to number 7, but nothing was productized.
That's
you
right.
came in to change that, as far as I understand.
That is correct, and not just me. We're gonna have to build a big team to go do it. Yeah, and it's across all these channels. So it's, as you know, from really successful companies in the market, like Synopsys and ARM, it takes a lot of work to take IP to market. Most people think it's easy. You develop something and you just give it to somebody else. No, there's a lot that goes into that, right? That's not as always fun work.
I've seen AI companies who started off building chips and then they've just turned into an IP vendor because they think it's easier.
That's right. Yeah. No, you talk with people at Rambus that have taken this journey, and others, but they make hardware, but they also make IP. And some of them will say, the IP business can actually be harder in many ways, right? So what we're going to do is collateralize the IP, make it supportable, quality, get customer feedback, customer engagement, create the ecosystem around it. The software's got to work, the tools got to work, the flows from Synopsys, Cadence, others have to work. And then we got to go build the product out, and it's got to be high quality. It has to boot. It has to run. It can't crash in the data center, right? It's got to be supported. It's got to be improved. You got to take customer feedback. So all those systems are being put in place, and we're developing it from the ground up.
So Tenstorrent nominally has 2 major product lines. If you take the 30,000-foot view, part of it is RISC-V, and part of it is AI machine learning.
Yep.
And there's this holistic idea that they be brought together in some sort of go-to-market, idealized situation, but the market is perhaps not mature for that. So you're going through that process right now.
Yeah, and I would think it might be more mature than most people think. And I think, both Jim and I were fortunate, and many of us were fortunate to be at AMD during this journey. And there's points in time in this journey, if you've been in the industry long enough, you'll look back and you'll say, you don't see it at the time, but when it's happening, you're like, this might not be really profound in the industry. And you look back 5 years and you say, wow, that was a major crossroads. Mm-hmm. We hit a major crossroads and may not have really known it at that time, but we decided left or right. And as soon as we went there and the rest of the industry followed us, the industry was never the same again. Well, what happened when AMD bought ATI for its $5.4 billion? I was inside AMD with a lot of executives struggling to put those assets together and get product to market. But as soon as we did that, and super smart people there worked out all the issues, the coherency and how we're going to integrate these 2 different technologies, the industry was never the same after that. People realized there's different engines you can apply to your workloads. And one engine is not going to be good enough anymore, right? In most complicated compute platforms, including your cell phone, right? Yep. You need different engines to get different things done. Well, AMD pioneered that back in the day, and Tenstorrent taking that to a new level, saying AI, RISC-V CPU, vector units, and even graphics. These are all engines that need to run different algorithms, and you have to put them together in a system where there isn't losses for having all those engines present, and the workload is dynamically shifting between these. To run the algorithm on the right engine to get the right job done with the right efficiency, power, performance. And it's here to stay. It's going to be adopted and morphed over time in various ways. And we think AI is going to become a part of that CPU RISC-V compute. So we see it as a platform, not necessarily 2 different pieces of technology. And I think that's the right way to look at it for the future.
So you say, looking back on some of these inflection points that you may not have realized they were inflection points as they were going on. It kind of sounds like you're talking as if you're at an inflection point now. So how does that change perspective compared to not knowing it's an inflection point, right?
Yeah, well, that's a fantastic question. And you don't know you're at an inflection point sometimes until you're past it. Sometimes it punches you in the face. And I remember this current AI buzz that's being generated by the market. I think it's the fourth time in history that the buzz has happened and AI is going to change the world. And when it happened for the fourth time, because I'm old, I've been around a lot, and I know that this has happened before, I was like, I'm not sure it's going to stick. And what did it for me was going to Tesla and working with Elon and all the smart people that were at Tesla. And I said, wow, it profoundly changes the automobile industry. And then I started talking with these folks that came from other places to come to work at Tesla. And I got it right that time. I didn't say Tenstorrent. I said, I got it right. I'm getting better. And what I found was we were coming from, retail and manufacturing, and even like some smart people had tentacles into like pharmaceuticals. And I realized AI was going to change everything. It's going to impact everything. And the technology was there and the software was becoming available. And it wasn't a fad. And, we've heard this before with the internet, right?
Yep.
Internet's here. The whole world is different. What happened is just the big companies adopted that technology and the world changed. It wasn't a new world. It was a changed world. AI's there now.
But the internet went through a big boom and bust and boom phase. We could argue right now machine learning has had the boom. Large language models are now so prevalent in, even colloquial discussions. Where's the bust? Is there going to be a...
It may or may not happen. I think hopefully as an industry, we've learned some lessons. There will be people that win in AI. There'll be people that lose in AI. I think you can bet that a lot of the big companies will continue to kind of be successful. They'll adopt it and they'll move forward. No one's going to get put out of business because AI was a surprise now, right? Everybody knows. But I think, there will be consolidation. There will be companies that try new things. Jim always says this. It's the industry needs to be a breeding ground of experimentation.
Yeah.
And Jim is a big fan of that. And that's one of the reasons why I'm here. It's so fun to just try different things and see what works and what doesn't work. And some things will work, some things will not work, and that's totally okay. You just hope you pick enough things that work that you get to the other side. History, we will know when we get into the future who picked the right path. But that's what we're doing. There's a lot of experimentation now, and not everyone's going to win.
Well, I mean, that makes sense with Tenstorrent doing chips, IP, chiplets, and all these different arrangements. The danger there being you might spread yourself too thin.
Too thin. It's a roulette table, right? And you're trying to place your bets. Place too many, it's not going to ROI.
Yeah.
Place too few, you may not win.
Yeah.
It's a delicate balance.
So a number of machine learning hardware companies in this space, mostly startups, are starting to realign themselves around the large language model concept because it has kind of taken off. You guys haven't done that, or should I say haven't done that yet?
I think we are. I think we are aligning ourselves along those algorithms, and the algorithms are going to change.
Yeah.
It's interesting. One of the things that we noticed, at Tesla was don't be too confident in where the technology is today. I've learned that many times in my career, and I'm sure you've experienced it talking with people. Is as soon as you get confident, you say it's LLM, and we're all in on large language models, and this is the way the world is always going to be. I think large language models is a stepping stone to something that's coming next. What's coming next? I think a lot of people can disagree and debate. But I think today you have to go through large language models to get to the other side, because that's actually driving the thinking, the architecture. What do you need to put down in your software stack? What do you need to put into your hardware? Because that's going to make money today. It's going to run today. To get to the next step that comes, the next morph in the industry, you probably have to go through LLMs, and we're doing it too.
Yeah. So aside from hardware, aside from IP, one other angle that a lot of machine learning companies are going down is also the ability to drive revenue through software. What's Tenstorrent's stance on that?
It's always been hard. Again, I'm old, right? I've been around for a while, so 30 years. I remember the discussions. Friends at Intel, people at AMD, when I was working at Motorola. Hardware companies have a really hard time monetizing software. And some of the biggest problems in the industry aren't technology, aren't money, it's human psychology.
Yep. So
when you're a hardware company, we have trained like 2 or 3 generations of people that if you're buying something from a hardware company, you're buying something from a perceived Qualcomm, IBM, the software should pretty much be free. But if you're going to a software company, you go to like Adobe or Borland or Microsoft, well, then you pay for the Pay for the software, of course, right? Those two worlds have not melded very well.
Yeah.
Right?
Yeah.
And you see it like in AMD, they have a lot of software engineers. Hard time monetizing them as a separate business. Same for NVIDIA. Same for Intel. Is that going to change? Probably not, because of the human psychology element. So monetizing software independent from hardware, if we were to do that, somebody like me, who's a business engineer, a business builder, I think we'd have to find a way to do JVs, partnerships, get it outside of the rubric of Tenstorrent. This is a debate I think we can have with a lot of people, and maybe Jim would disagree with me and the board. But I think monetizing software and hardware in the same company hard. Let's find a way to do it through partnerships, or maybe a JV or some other company. Get that a different brand, a different look, the optics.
So with the announcements you've made to date with customers, I mean, LG's been one of the big ones. You've now got strategic partnerships with Hyundai and Samsung, and no doubt there are some others coming down the pipe. The biggest question I get asked from the people out there is, when can I get my hands on one?
Get your hands on
a card, on Tenstorrent hardware, such that they can learn how to use it.
Yeah, we have. So we're going to be putting the systems in the cloud. Yep. Our software is improving every week. Just came out of a meeting talking about that with our ecosystem partners. So you can get on the cloud. You can use it today. We have wormhole cards, G.Skill cards we can sell today. We have software that'll run on it, models that can be tested. But it's a journey. I mean, I've seen the struggles that even NVIDIA has gone through in this market. You know, an interesting corollary is this. Let me take a step back. Most of us don't remember. If you go back into the 60s, and I can almost go back that far, if you go back in the 60s, when CPUs were coming out, computers, you get in the 70s and the 80s, a lot of us were running assembly language. When I was in college, I was writing assembly language right on VAXes.
Yep.
That was the great way to do it, because compilers were terrible. And I remember talking with people back in the 80s and 90s, these compilers are terrible, writing assembly language. So we had to take a 10, 15, 20-year journey to get the software to where it was to work well. We see that struggle now with CUDA and everything else. We're going through what was the early stages of the CPU development cycle in the 70s and 80s, where everything was a surprise, everything was new. Something happens and it breaks the whole ecosystem, and you got to start over, do that. We're experiencing a little bit of that now. We're accelerating through that faster, because everything's faster today than it was in the 70s and 80s, right?
Yep.
So, it used to be we would take 10 years to get to market and get 150 million users. Now we can do that in 3 months, right? So everything's moving faster. We're going to move faster through this AI cycle. The software is going to stabilize. The hardware is going to stabilize. We have hardware and software out there. It's not without its issues. It's got to be developed. CUDA's in the same place, although they've got a 10-year or more head start on everybody. Yep. But people are rapidly closing the gap and catching up with them. But it's a journey. So the software is out there. We need customers to be using it. We need customers to give us feedback and say, this needs to be fixed. This needs to be fixed. We need these features. We're going to take that journey just like CUDA did. We're going to take that journey just like the CPU business did 40, 50 years ago. And we're excited about the journey, but that journey has to be gotten through. And we need customer input to get that journey complete.
So the machine learning companies typically fall into one of two categories. One is the engineers who...
Winners and losers.
There's that too. And you can perhaps guess which one I'm going to go with this. You have engineers who think this architecture is a good idea and put it out. And then you have companies that have customers who say, the customer wants this, so we'll design for the customer, right?
Yeah.
Where does Tenstorrent fit on that scale?
In my experience, it's always a balance.
Yep.
So I'll talk from both sides. This is a great reason why you go to law school.
Right.
It's because I can argue any side of any argument with passion and vigor. Right?
But can you win?
But can you win, right? So if you sit from the customer side, what I've heard so many times was, well, the customer really doesn't know what he wants or she wants, right? And when
if you ask everybody in the early 1900s what they want, they would say they want faster horses.
Exactly. Yeah. Nobody wants a Model T. Yeah. We want a better horse, right? And so there is that in the market that you have to deal with, where the customer may not know what they want. And you can see it in SpaceX is a great example, right? If you wouldn't have designed that business from first principles, you would have made the same inefficient business that is the Russian Space Agency and NASA. No, blank sheet of paper, first principles. Yep. Don't go in a different direction, and it's fantastic. So I think you have to listen to the customer. and you have to get their feedback. And then at the same time, you have to say, what can the technology possibly do, and strike the right balance. If you're just building something because you can build it, you're probably not going to be successful.
Yep.
And there's so many companies doing that. There's great technology. Just because you can do it, you can't use it. Just because you can do it, you probably shouldn't do it. You have to know that if I build it, somebody's going to pay the bills, and I can be successful as a business. And at the same time, you don't want a customer pulling you down a path. That's the wrong path for the market. So you have to take feedback from both sides, and you have to have intelligent program managers, TPMs, and engineers, and GMs that hopefully pick the right path. And history is replete with people who pick the right path and the wrong path, right? It's not easy.
Yeah, for sure. So this was perhaps a little bit before you joined, but I wonder if I can get your thoughts on it. The way Tenstorrent's future roadmap is progressing through the RISC-V side especially, you've got these baby risks in the 10.6 cores, and then the reach out to SiFive to enable SiFive's cores in the custom design, and then for some reason going fully custom with RISC-V. The impetus behind that, and arguably, if you're relying on your own design rather than somebody else's, then the liability is on you to get it right. But the benefits therein outweigh that. Is that the general feeling? Yeah,
I think one of the big things that is valuable about creating your own technology is you can do it the way you want to do it. Generally, it's more expensive. Generally, it's all on you. You're on an island, right? It's like you don't have some other person to ask for help and support. But one of the things that we've seen in the market is in a proprietary platform. And this is not to knock these platforms because they have their place, right? And they've been very successful in the market. x86, very successful. ARM, very successful. But if you go to these ecosystems and you say, like we did, Jim and I at Tesla, and if you say, hey, ARM or x86, I want you to support these data types. And I'd really like you to do this with your microarchitecture so we can pass pointers back and forth between different compute engines. Like I talked about earlier, have these different engines effectively and efficiently run different workloads. Well, ARM and x86 have about their aggregation business means they have to work to develop a platform that works with everybody, and then they have to support it for everybody. And if you're not careful, if it's too different, it breaks. So there's power in that you can go to ARM, you'll get something that's stable, but everybody's got it. Right? So that's the problem, the con with that business. So the other end of the spectrum is, well, if I do it myself, I can put in there exactly what I want. But then you're on an island by yourself in some way, supporting it with your compilers and your ecosystem. There's a balance between that. And there's some times where you take the aggregation model and you take something off the shelf, and it's good. There's other times where you can't succeed in your market unless you go do it yourself, because these ecosystems that are proprietary and broad across the customer base, they can't support you, and they shouldn't. It's bad business for them. Right? So it's good business for us to grab the technology we need, custom tailor it for the solution that we need to provide. So we're providing maximum value for our customers. But like you said, when it breaks, we own it. When it works, we own that success too. But that is a challenge that we face going forward.
So particularly with RISC-V, there's obviously RISC-V International, the standards body. How far along the road inside Tenstorrent to say, well, let's do this, this customizable design, this scalable design, and then let's feed back into the standards to get wider support, wider adoption. Is that in any level of priority?
I think it's absolutely a priority. I think Jim's passionate about it. I'm passionate about it. I think what we see in the market is, and Jim says it this way as well, is that going from a proprietary platform to an open platform is a one-way door. Generally, once you go open and you've now invested in that and you've developed it, going back to pay somebody a lot of margin for what they're giving you that you can't control and morph and change and customize and differentiate, it's not a path you want to go back to. So Linux is to kind of Windows what, I'll use RISC-V as an example, what RISC-V is to ARM and x86. The technology isn't what differentiates the two. It's the business model. And we kind of talked a little bit about it here. And it's, if you build in that, RISC-V ecosystem, you can do what you need to do when you need to do it and build it out and share it with others. And the force multiplier you get working in an open ecosystem is immense. And that is now coming to hardware for the first time. We've seen the benefit in software, and we've seen companies like Red Hat exit for $34 billion to IBM. So people say, well, how do you make money in open source. I say, go back and read history. It's been done already. We don't have to have this discussion. And I think that's also going to happen again in hardware. So open platforms are going to have the benefit of do what you want, when you want, customize, differentiate, leverage a big ecosystem that you don't have to pay every dollar for to go to market, faster time to market, free thinking. The disadvantage of that could be chaos. Does the ecosystem work? Does it break? Jim is committed to making this happen. Tenstorrent's committed to making it happen. I think if we have open platforms on AI and RISC-V, we'll drive down cost. Everything will get better, which is why we're putting flexible business models in place with customers. We don't have to own the technology. We don't have to lord over you as a customer for the next 20 years and take a lot of your profit and margin. How do we, with open platforms and with broad licensing of technology and co-development, how do we make you successful? We think that's still going to generate a lot of value, just like it did for Red Hat. So we're committed to open platforms.
So pivoting slightly, I have to assume part of your role is also being involved with the foundry relationships.
Oh, absolutely.
For manufacturing. And we've seen Jim present at pretty much every major foundry conference around, and Tenstorrent's been open with global foundries and TSMC as partners. From a personal perspective, I really want to know how those relationships work with a smaller player, in terms of NVIDIA, smaller player, right? Versus how those relationships progress and how you're relying on them to execute on their roadmap as it aligns with yours, and how you bring that to potential customers.
Critically important. I would have to say, like the fabrication companies, the manufacturing companies, like TSMC, UMC, Samsung, global foundries that you mentioned are probably the most important part of our ecosystem. You can look at other things like CAD tools, incredibly important. You can look at IP providers, important software. But when you look at the fab business, it is a business, high capital, high risk, that you can't do it yourself. You can build the IP yourself. Yeah. There might be other things you do yourself. Very few people are going to go spend $17 billion on a factory and be successful and compete with any of those. It's done. That ship sailed a long time ago. So you have to rely on these companies to be successful. And there's different things these companies can do for you to help you be successful. We've seen it with the relationship between Apple and TSMC. Yep. The relationship that Tesla had with Samsung, that in the early days Apple had with Samsung. Jim and I have repeated that over and over again in our career. I did that a little bit when I was at SiFive. I did it with Google, with 4 Tensor chips at Google. You have to partner very deeply with these companies. And for a company like Samsung, who's an investor in us, as you mentioned earlier, it's not just about the foundation of foundry technology and silicon processing. It's all the other things they bring to the table that make them a good partner. So the other thing, when you go talk to these foundries, especially Samsung, it's not just about, can you build me wafers and what's coming in 2 nanometer and 14 angstrom next. That's a very isolated conversation, but it's an important one. And Apple makes a lot of money doing that very well. Yes. And so Tenstorrent is doing that now too and looking out at the advanced technology. But we're going further and we're doing it out of necessity. Necessity being the mother of invention is, okay, we need design services and we need access to IP. Then there's back-end packaging. And you know what? We need memory solutions and DRAM. And chiplets, we can't do this by ourselves. What about the interconnect IP? When you have a conversation with a company like Samsung, with a track record of making companies like Apple and Tesla who they are today, that is a powerful discussion. That's super important. And like I said when I introduced myself, I go into companies where there's multiple dimensions that need to be woven together. Financial, IP, technology, people, processes. Pull that together, make that happen. And if you don't do that well with your foundry, whether you're a startup or you're a big company, you won't be successful. So we're doing the discussions just like Apple's doing, but maybe a few less zeros on the numbers, but the structure is the same.
Yeah. Okay. Because that leads me to the important question. It's an isolated part, but it's an important part. This need to be on the leading edge. Yeah. It's obviously Apple plays it really well, and a lot of other companies compete in that space, and they compete because machine learning ends up being a very compute-heavy task, and you need dense logic and high performance. However, the cost of enabling hardware on these more advanced process nodes, the cost is increasing. So
extraordinary.
How does a startup like Tenstorrent compete with the big players, if they have to compete with the big players on that front? Is it, aside from being smarter with your resources, being more agile, is there anything you can do? Yeah.
I mean, part of it is, partnering with a company like Samsung can help you with those finances. If they look out into the future and say and think, Tenstorrent being successful means we, Samsung, will be more successful, then they're willing to kind of help you along the way with those financial.
Okay, they give you a better deal.
They can. Yeah. They can, right? Because, and by the way, they're not doing that because they're in the charity business. No. They're doing that because that's going to come back and pay them dividends later. But again, I build businesses. You have to strike that right balance, pitch that narrative, and make it work. But, I think even more than that, the industry is broken. I mean, I was at Google, I was at Tesla, I was at AMD, and we're looking at these price curves, which just in the last 5 years have gone exponential. Yeah. And you look at the price of wafers going out to 2 nanometer and beyond with CapEx equipment charges from ASML, who's a monopoly basically. There's no place else you can get this technology. They're charging, $500 million. When you talk, and you're sure you've had these conversations, when you talk in the background of, hey, what are these high aperture 0.55 NA product looking like when you're going to buy them and install them in 2 years? $500 million a piece, right? So this is not cheap. They have to make that money back. And so this is where chiplets come in my view. Chiplets, the FPGA guys took that journey a long time ago because they needed the silicon surface area. Then DRAM did it because they wanted to deploy more DRAM. This is not new technology. Then AMD and others did it successfully, Rome, Ryzen, and other things, which everybody can read the press on. This is now coming home to roost in all the markets. And it is one way to solve this cost problem because all of these companies that came before us, right, the DRAM companies like Micron and the FPGA companies, Xilinx, Altera, you have AMD, they have pipe cleaned this process. The testing is getting better. The interfaces are getting better. The losses you have from carving your architecture up into pieces and Legos and then gluing them back together in a complex package with ASE and Amkor doing this work, it's gotten better and better. And I think that affordability and that ability to go to market faster with product and to be able to parse your design apart and run some at global foundries if you want a trailing node that's at a better cost and do only the 20% you need to do at really advanced 3 nanometer technology, you can pay for that $20,000 wafer or $30,000 wafer, God knows where it's going in the future, but still get the yield you need, the performance you need at the cost price you need by leveraging this chiplet ecosystem. And that's a deep rabbit hole. There's a lot you can talk about there. But if we can crack all the problems, the complicated problems that are in that technology, and we're doing it week by week, that's a solution to the cost problem you just talked about. There's probably other things out there, but that's one everyone's looking at.
Because this is where I want to bring up non-recurring engineering costs, right? It's not very much the wafer being expensive, but you still got to put in the couple of $100 million to design, even if it's a chiplet, regardless of whether it's 800 square mil or 50 square mil, right? So I think that's a major limiter for startups right now.
Yeah, it's coming. So you're talking about, well, you have to design the package. You have to design like the interposer, the organic substrate.
You got to pay for the masks.
You got to pay for the masks for the individual chips. So if the chips are already developed and sitting on a shelf, and you can amortize that chiplet across many designs, then that's valuable. I've had this I just came back from an Asia trip, 2 weeks. I had this conversation with countless companies. You can't look at chiplets as, all right, I'm going to carve up my design. I'm going to do an IO subsystem tape out, 12 nanometer, and then a 3 nanometer compute tape out, and then I've got multimedia glommed on here. If you look at all 3 of those tape outs with 3 different design teams, and then the underlying complicated interposer package with the test plan, it doesn't make a lot of sense.
90% of the cost is still in that 3 nanometer chiplet.
It is. Well, it can be, depending upon how big it is, and the NRE and the development cost of it. But there is a point at which it crosses over and it gets cheaper. But here's the catch. Here's what people are starting to find out. You can't look at this product by product. Yeah. You have to look at this over time on a portfolio basis. So if you are a big company like maybe a Samsung or an AMD, you have to look like AMD. We'll take AMD as an example. You can look at embedded, tablet, PC.
Reuse of chiplets over multiple product lines.
Now, if you can invest that one tape out and you can monetize it in 5-10 different places, and you could do that every year for 5 years without having to refresh. Now you've got something. And this is the exercise. This is the business engineering people have to do now. and we're waking up to it.
Yeah.
So more on that. It may not work, but we have to look at it.
Okay. Pointy question. Are you guys in discussion with Intel Foundry?
Intel Foundry, we talk to everybody that's in technology. And Jim, came from Intel. And we've got Tanuja and other executives here that have come from Intel. And yes, you can't count out Intel. They're a very capable company. They have great technology. You have to know what they're up to, and you have to see if there's ways we can intersect. Plus, it's like working with a Samsung. Intel is a much deeper company than just one dimension, right? They're working on UCIe for chiplets, right? They're a company that also knows quite a bit about integrating platforms into the data center. So if you're a tech company in AI and you're running some complicated silicon, if you're not having a conversation with Intel, you're probably making a mistake.
Yep.
They may not work for you in the end, but you better be talking with them.
Is talk cheap?
Talk is actually pretty cheap if you go to the right restaurants.
Okay.
And you do domestic beer, not imported beer.
You say that to a European.
Exactly.
Right.
Well, because your beer is always so expensive.
Over here, maybe.
Yeah, exactly.
Then there's a comment about beer and water. I'll steer clear of that. So Tenstorrent, I perceive the next couple of years as Tenstorrent working really hard on the productization side. The engineering today has been, we've got the underlying understanding of those multi-generation products, and now with the new target of chiplets and IP and the engagements that have been announced. But really right now, it almost feels like a zero revenue company, right? So go to market is the next 24 months. Yeah.
Yeah, and we've got bookings now in double digit millions.
Oh, cool. So
and that's
what, each or total?
When you say each, what do you mean by each?
Each customer?
Oh no, total. So if you, and by the way, that's not the big guys. We're landing some of the tip of the spear. The mid tier, smaller companies, landing them and getting them going. That's not including the bigger stuff that might be on the horizon with people we put in the LG. Maybe Samsung, maybe Hyundai, all these, So it's going well, and it's starting to head down that path. But now I forgot the question. So what was the question again?
Is the next 24 months is essentially the go-to-market revenue generating side.
Yeah, and that's why I joined. Jim wouldn't need me if it was technology development, unless he needed me to build out the ecosystem, which, he did a very fine job with people. What he needs now is to take this into a business. Yeah. So the technology needs to be turned into a business. A lot easier said than done. There's a lot of dimensions here we have to do. It's got to be sold. We're working with Dave, who you interviewed as well. We've got a pretty tall order in doing this. Any company does to go build this. But you're right. It's about the relationships with the contract manufacturers, the foundries, who we've just talked about, so you can run your silicon, your sales out channels, and how do you move this to market? How do you structure your customer deals? We already talked about the complexity of the sales out channel. It's IP, it's chiplets, it's cards. It's so putting all this together in a way where you also can make your sunk costs and your operating costs over time gel with, hey, we're going to be break even profitable at this point according to our scenarios. And then, our VCs, you know what? They actually want to go out for an IPO, like a big M&A. So we've got to plot a course in that direction. All those puzzle pieces need to be pulled together. And Jim wouldn't need me if he wasn't at that stage in his journey. And so that's the journey we're taking now.
So I pose this question to David, and I'll pose it to you as well. A lot of the announcements so far Tenstorrent has made relate particularly to automotive. There's a little bit of data center in there as well. What are the other key verticals that Tenstorrent are targeting, right? I've got to imagine there's some big fish out there that need to hear about you guys. Yeah, absolutely. And you never know where you're going to win. Using, again, I try not to talk in just abstract examples. I try to give real examples. So when we were at AMD, tell some war stories. It's like we really didn't know how we were going to get through the tough times, right? The 2008 through 2012, where we're all concerned about cash. And then the game consoles came in out of nowhere. And a lot of people didn't like that business. It was low margin, but you know what? It paid the electric bill and the leases and the salaries and got us through to where AMD is today, and fantastic company growing with a lot of prospects, right? So you never know where the next meal is kind of coming from in many ways, especially when you're a startup. So we put a lot of hooks in the water, talking about a fishing analogy, and you don't know what fish will hit. Surprisingly, it's usually the automotive guys that come 7 years later. Yeah.
Well, Tesla's changed that, right? So the automotive guys are biting faster and harder, and Hyundai's way out in front of everybody else with their thinking on technology and EV cars and where they're going to go with the market. And they're putting their money where their mouth is. They're investing, and you can see that across the board. So they're moving where some of the car companies are still being a little lazy. So that one landed, and it was kind of a surprise. So now we're building up to go address that market because Hyundai's invested, and we're going to go make them successful, and they will in turn make us more successful. And then we've got other people that have been biting. We thought it would be all data center. Yeah. Right. That was a lot of our, our
initial interest.
Yeah. Right. And that's what we started building for. Now we're hearing with where ARM has gone in the last, year or two, the phone's ringing off the hook for RISC-V. And it's ringing off the hook in Android ported devices and mobile and consumer electronics. Right. That's where the volume is. So now it's like, ooh, you're going to miss a big TAM and a big opportunity there unless you're addressing that. So we're fielding those calls and those opportunities. And then we're seeing the typical data center ones that we started with. We're also seeing, IoT, embedded consumer electronics things, which is really visible in our LG announcement. It's like, we don't need 700, teraflops of compute. We're going to put this in a TV. We're going to put this in some home electronics. And LG, we're working only, and this is an important point to make, we're really only working with customers when it comes to development of technology in areas where they've got incredible capabilities they can bring. Samsung, incredible engineers. LG, Hyundai, incredible engineers, capable in silicon. And they're putting people and technology and brain power behind this, as well as money. Money's good, but money's not enough in this. So we're not doing all the heavy lifting ourselves. That's important. And so these markets and these things that are landing for us, we're working with capable companies. We're not high risk and out over our skis. And so those markets are the ones that have hit with capable customers that are bringing technology and co-development to the table and helping us move forward.
So it's interesting that you bring. We spoke about Hyundai a couple of times, and from my perspective, the car business is much like the embedded business. It's 7 years. They work on something for 7 years. That's going to be on the market for 15. But that means the check's going to come in 7 years.
Yeah.
Right. So what? From a startup perspective, or at least from outside a startup, it kind of feels like, why would you partner with an automotive company?
Yeah, and it is true. And I worked at Motorola in the automotive business way back in the day. And it's true. It takes you 7 years to get in, but then it takes you 14 years to get out, right? Because they're in. Once they're in, they're in.
Yeah.
Right. And the companies have realized especially like what Tesla and others have done with the business now that, hey, it's going to take a lot of investment with technology to make things that are going to go in the car 3-4 years from now. And in a startup, if they value what you're doing, they will say, well, we'll bridge you to that 3 years. We'll be buying a lot of parts from you in 3 years, but that's not going to get you through today. So it's investment, it's NRE dollars, it's, hey, we'll license some IP from you for our engineering teams. They will find a path through to fund you to that utopia that hopefully is coming in 3 years, right? And by doing that, they get some of the benefits, right? They will get investment in your company that's upside, faster time to market, differentiation. They'll influence your roadmap down a path. So if you find a few companies in your development ecosystem that you believe in, and AMD has figured this out a lot, Intel Capital, you invest in them, you bridge them, you help them get through, because when they get to the other side, NVIDIA and Qualcomm, they were all small ones too. And they had somebody that got them to the other side. And so these big companies have to get these companies through to the other side and bridge them because, like you said, it takes a long time to ship 20 million units off to LG or Ford or whoever, right? So
you also brought up the some of the initial deals that you guys have been making with essentially RISC-V replacement for what could be Android type devices. You have a history with Google. Does that help?
It does. I know a lot of the folks over there at Google. But Google's doing a lot of the stuff on the inside. Right. They want to do to the market and the Android ecosystem what Apple has done, for iOS, and it is a good strategy. That doesn't mean that Google won't need some help from the outside, and they certainly understand that. You can see that in the deals that they've done. So yeah, we would love to help Google get to where they need to go. We'd love to partner with them deeper on Android and making that conversion over to RISC-V, and those discussions are always happening. But a lot of times they can go it themselves. They're big enough, and very few people can go it themselves. So
yeah. So I know we're coming to time here because you're a very busy man. But one of the things I wanted to touch upon is the fact that you're not only just COO of Tenstorrent, you're also a board member. I'm not necessarily somebody who's keeps track of the top management of who does what where sometimes at that level, but can you go into detail about what that means for your roles, both being COO and board member? Does it just mean that if you're stuck in the weeds, you don't have visibility?
No, I think what it'll do is it'll supersize the role that I have right now in the company. So it'll pull me up to work on more strategic things at the board level, largely reaching outside of the company and tapping networks, right? That's really what the board will do. It's like JS and Greg, and then our observers like Adam and, Dede and Marco from Samsung and Jason from Hyundai. Really where they're helping is let's make the connections for Tenstorrent to make them successful. Let's make sure they're not missing the big vectors and disruptions coming in the market. They don't miss that opportunity over there in Japan that they may not be focused on. It's big, like, steering of the battleship. And Jim said, and the board said, and I'm honored to have done that. And Raja, by the way, I should mention Raja, who's on the board, which is a huge asset, right? I want to join them and say, given I have a different vantage point and given I've had a different path I've followed, and I'm a business engineer as opposed to, Raja, great technologist, and GM Jim, we got financial guys that come. I'm going to bring hey, let's pull together the legal, the partnership, the engineer, the business, the operations, the risk angle. And then I'm going to help steer the ship and drive it down new paths. Like we talked about earlier, that's where we're at in our stage of growth. And so you don't need a guy like me on the board when you're developing the technology or when you're raising just the money, and that's what's important. But we're far beyond that now. So I'll bring that talent and skill to board level.
You say missing vectors. Do we have to say missing matrices now?
Yes, we do.
That's awesome. Thank you so much for your time, Keith. And thanks to all you guys for watching. We will undoubtedly have more content relating to Tenstorrent, especially as, when they give me a chip to unbox. That will come soon, I hope. But again, thank you to Keith, and thanks you all for watching.
Thanks, Ian.